Like, subscribe and press the bell icon for more videos from PHN Learn. For more videos, download our app from the Play Store.
Hello all, welcome to PHN Technology Private Limited. Today we are going to learn more about bitwise operators. In previous session we have learned many different kinds of operators. Now we are going to learn what are bitwise operators. Now this name only suggests that bitwise, it means it does the operation at the bit level. And now where it does the operation? In my arithmetic logical unit, which is in my CPU. And what does this bits means? Bits means zeros and ones, my binary values. It does the operations with this zeros and ones, and that's why it is known as bitwise operators. Now you will think that where these bitwise operators are used. These are used in embedded softwares where you want to work with zeros and ones. For example, you are developing a game. There you have to specify the mouse positions and where we write the positions in x and y axis. There we have to use this values, that is 1, 0, 1, 0, 0, 1. We specify in graphs like this, right? So there we have to use this bitwise operators. From there we have to do the calculation using these bits, that is my zeros and ones. These bits are usually used in embedded software, mostly. Okay. Now there are many different kinds of these operators, that is OR, AND, NOT and XOR. Let's say one by one. Firstly, let's see an example that I have a switch over here. Okay. And I have one LED and two LED. Here are my LEDs. Now what I want, the moment I on the switch, see the switch is on, my two LEDs are on. Right? Now we know that in binary language, on is my 1 and off is my 0. Right? Similarly, here also, what happens is, the moment I have on the switch, my two LEDs are on. Now let's take an example of OR statement. What are my OR operators? In OR case, what happens is, for example, let's consider this LED is off. Some connection issues and it is off. And this is my on. That is, this is giving me one value, that is true value, and while this is giving me off, that is 0 value. That means the condition is 1 and 0. Then in OR statement, the answer will be 1. Similarly, if I did vice versa, that means now this is on and this is off. Now 1 and 0, then what happens? Again the answer is 1. But let's consider now both LEDs are working and they both are giving me on. That is, they both are giving me answer as 1. 1 and 1. Then what will be the case? Here also it will be 1. And if both are off, then 0. That means 0 and 0 is equal to 0. Now, this was, see, I have created a OR truth table here. This is my values of OR. Now, by seeing this truth table, you can judge whenever there is one or more than one or more than one, then what is giving me? It is giving me 1 itself. In the last statement, you are seeing that there are 0, 0. There is no 1 over there. Then it is giving me 0. Here what I conclude is, in OR statement, in OR operator, what I get, if 1 or more than 1 is true, that is 1, that is on, then I will be getting 1 itself or else 0. So this is how my OR truth table works. And how in bitwise operator, how this OR is represented as this single line. Okay, so this was my OR. Again, if you want to see AND, let's take an AND here. Now in AND, what happens? You want to have at least more than one ones. Then the answer is 1. See, if it is 0 and 0, then I will get 0. 1 and 0, then also 0. 1 or 0 or 1, then also 0. And 1 and 1, I will be getting 1. So this is my truth table of AND. Right? So in AND condition, what happens? We have to get more than 1 once. More than 1 once. Then and then only I will be getting the answer as 1 or else 0. In the last case we are seeing here, there are 2 ones and hence I am getting 1. But in the rest I have only 1 or no ones. Then I am getting 0 because I want more than 1 once. That is more than 1 on true value. Okay, so this was my AND and it is represented as this single and person. Okay, now comes NOT operator. NOT is what? NOT is a unary operator. That is, it works with a single operand. Whereas AND OR was binary operators. That means to work with those, you have to have 2 values, right? We were having 2 LEDs. I showed you the example. There we are having 2 values, right? So AND NOR are my binary operators, whereas NOT is my unary operator. NOT gives me the complement of a particular value. Let's say, for example, I have 7. See, I have 7. 7 is written in binary language. 7 is written like that. Okay, 0, 1, 1, 1. Now, if I take the complement of this, that is, if I not this statement, that is negation, then it will give me like this 1, 0, 0, 0. What has happened now? It has reversed the value. That is, wherever there was 0, it has given me 1, 1, 0, 1, 0, 1, 0. So what it does? It converts the binary values. That is, if it is 0, it converts it to 1, and if it is 1, then it converts it to 0. This is the work of NOT. And now for 7, if I get the negation to 7, I am getting 8 binary value over here. Right? So this was my NOT. And again one type is XOR. This is the new type over there. This is my XOR. Now in XOR, what happens is, the condition is I have to have 2 values. That is, 1 should be true and 1 should be false. That means 1 should be 1, 1 should be 0. In terms of LEDs, I should have 1 off and 1 on. Then and then only I will get a true value over there. See, this is my truth table of XOR. Right? So this XOR, see, when it is 0 and 0, then it will give me only 0, because here condition is 1 should be true, 1 should be false. But here both are false. And in the next 2 and 3rd step, I am getting 1 because I have satisfied the condition of XOR. And in the 4th statement, it is giving me 0 only, because here both the values are true, none of the value is false, hence 0. And this XOR is formed as, stated as this sign, XOR sign. Okay. So these were your bitwise main operators. Okay. Now, again, how you can, there are many different kinds of bitwise, that is, those are shift operators. Right? Left shift, right shift. Now these shift operators are what? Now let's say for a consideration, I have 6 value over here, right? That is, I have given 6 value and it is represented as this. Okay. Now what I want, I have given, let's say A is equal to 6, then I will add A left shift 6. A left shift 6. Then what will be this answer? Now remember, in left shift we multiply. That means what will happen, that firstly it is 6. So 6 into 2 raised to the power 6. 6 into 2 raised to the power 6. There I will be getting the answer. See, this will be my output over here. Right? So this is how your left shift operator works. It gives me the answer while multiplication. Okay? And similarly, if you consider right shift operator, then what it does, see over again let's say I have 6 only, right? I have 6 over here, then what will I do? I will have division over here. There in left shift I have multiply, here I will divide. That is 6 divided by 2 raised to the power 6. Now we all know 2 raised to the power 6 is greater, so we will get 0 point something. So ultimately, because I have given int A, therefore I will be getting 0 as my value. Because I have right shifted it, so now the value is 0. So this is how your left shift and right shift works. Okay. Now this was all about your bitwise operators. Now let's consider example. Now you have studied bitwise operators, but you know that bitwise and logical operators are one and the same. Here only what we are using? Only we are using single, while here we are using double. That is double ampersand, single ampersand, single slash, double slash, same. There also we have and not, and or operator. Here also we have. But then what is the difference? Now, consider an example over here. So this is my screen. Now I will write int A is equal to 3, let's say B is equal to 2, 4, okay. Then here comma, then if A ampersand B, then printf result of A ampersand B is 1. Okay. Again, if A ampersand that is logical and printf result of A ampersand B is 1. Okay, semicolon. Save this code. Now let's see what will be my answer. Okay, let's run this code and see. Result of logical operator, logical AND operator is 1. Now that means that is the value. This if statement is becoming true, whereas this is becoming false. Now, why is it so? Here, because both the values are my zeros. After ANDing it, I am getting as 0. Why is it so? Because we know if I get, see, in the above, there is 3. This is my 3 binary value and then again 4 binary value. So, in AND we know that, in bitwise AND we know that we want to have more than one once. Then and then only I will get an answer as 1, or else it will be 0. So, here the result is coming as 0. Because there is no, when I'm comparing it, there is no 1 more than 1. double 1. Hence, it is all the combinations are 0, 1, 1, 0, right? So there I will get complete 0, and hence I am getting there 0, that is false value, and hence it is not executed. Okay. Whereas in logical, what happens is it calculates the value over there. That is 3 ampersand 4. What is true? It is definitely true. It is not evaluating using the binary values, right? Because that is a logical operator. But in bits, there was doing the calculations using the binary values, and hence we were getting condition like that. Here we evaluate by through Boolean values. Here we only get value as true or false, right? And so 3 ampersand 4, that is 3 logical and 4 is true, and hence I am printing that. Result of A ampersand B is 1. So this is the major difference between bitwise operator and logical operator. So remember, bitwise operators are definitely used for bits manipulation, whereas logical gives me Boolean values. Okay, so this was whole year bitwise operators. Okay, so this was it for you today's session. In next session, we are going to learn some more topics about C programming language. So for now, goodbye and thank you.
For more videos, download our app from the Play Store.